Good morning, all of you, and welcome to this Geopolymer conference of the year 2016. I would like to thank Professor David Roberts for giving me this opportunity to present what's happening in India. In fact, he has been a great inspirator for us in taking this project of Geopolymer into a very great extent. I'm just sharing some of the experience that we have encountered in the last couple of years. We have just about three and a half years in Geopolymer, but we have been very successful commercially in India, and we have some very good information and news to share with all of you. See this, we're going to talk about some practical issues in commercialization of a Geopolymer. Actually, Geocement is our brand name. It's a registered brand name, and we have a couple of registered brand names which will come a little later. So I'll just give you a brief about our company, Kiran Global, and we are the largest manufacturer of sodium silicate in India for the last 35 years. And we are the second largest in the world, and we are present in 6 countries. And we have 33 manufacturing locations, and with an installed capacity of roughly 0.8 million tons. And the research center in our Chennai in India is the approved silicate research center of the Government of India by the Ministry of Science and Technology. So that is where we did a lot of work on not only geopolymers but also on value-added silicates. Honestly, we started our research in the year 2012 and 13, and we have progressed quite well in the last couple of years. Early of this year, in January 2016, we launched our product in the meet, and in the presence of a lot of builders, architects, and other people. And it was a very welcome move, and I thought we were the first one in India to launch. We would like to be the leading player of geopolymer hardeners. I changed the word hardener here upon our Professor David Roberts, who told me a couple of months ago that don't use the word activator, because we were calling it as activator, and immediately we changed it to hardener, and in fact we are changing it as an accelerator. We would like to establish about more than 250 channel partners will be working with us on the geopolymer products the next 2 years. And we would like to establish a 2 million ton capacity of liquid accelerator with 4 million tons of binder powder and about 3 million tons of precast geoconcrete in the next 2 years. And this is a part of our Geomission, where we would like to have the earth-friendly materials to build green building products, and we would like to be present globally. A brief about the manufacturing of silicate. There are 2 processes which the gentleman from Walden yesterday told you, that we do both fusion and dissolving process, and also the direct hydrothermal process. In the fusion process, we use the sodium carbonate and the silica sand, and in the hydrothermal process, we use sodium hydroxide and quartz. We are also making a lot of blended grades of silicates for accelerators, and currently a new product that we have evolved is using accelerator using feldspar. I've got some samples which I'll show it to you later. Yeah, as I told you, between the last conference and now, I'm just going to share 12 months of my experience on the areas of accelerator development, on an areas of application of geopolymer in different areas, and our observations and recommendations. I think this will be very useful to most of you here. Yeah, as a part of the presentation, we have the milestones last year and what facilities that we created to cater to the market, and our future roadmap and the business plan, and what's all about this channel partners. I think this is an innovative idea with which I think we want to take it up much faster into the world. And I give you some recommendations which I think will be useful to most of us, and how we would like to be present globally. What are the milestones? In September of last year, we installed an exclusive accelerator facility to manufacture Geopolymer accelerator. Between September and now, actually we have 33 people making sodium silicate, but we have one exclusive facility for making accelerator. We have set up 3 more plants in this last 7 months. The December of last year experienced one of the worst floods in Chennai and in Tamil Nadu, in south part of India, worst in the last 80 years. So what we did in the city of Chennai, we took a vehicle and took our geopolymer concrete and went all over the streets and just filled up the potholes as our part of supporting the government and also those who are. And it was a very welcome move, and that is how we got noticed. And we have been invited by the various agencies to come and present a lot of this exercise in their other roads and repairs. And with that encouragement only, we were able to launch our product immediately thereafter in the month of January, and it was a very big launch. In the month of March, we have created a facility for manufacturing about 50 to 60 tons of precast geopolymer products. These are being currently used in some of the projects. During the last conference, I did mention and promise that we will erect the first geopolymer building in India. And we did that now, completed last month. It was a 15,000 square meter building. It is our own building, a factory which was constructed for manufacturing precipitated silica. We didn't do the structural elements which were done earlier. All non-structural elements, the roads and everything was done using geopolymer, and I think it is a very great experience for us. So these are some of the projects that we have been executing, and we have already executed more than 65,000 square meter of geopolymer paver blocks. And the first one that we started is to construct a quarters for our laborers to stay on a 1,200 square meter area, and this is how we started our first work. And as I told you earlier, the 20,000 square meter of precipitated silica factory, which underground water storage tank, it's 1 million liters of water storage, and we constructed the effluent treatment plant and a chimney of 16 meter tall, all from geopolymer concrete, and of course all non-structural elements, and as I already told you, the structural elements were finished earlier. I was going to show the photograph also. Another one is we have made the coastal armor. That's the tetrapods that we made samples and we got them approved, and we are going to execute a big project in Maldives. It's going to supply about something in the course of about 6,000 tons of geopolymer precast tetrapods every month. At present, we are constructing a cottage, a villa, for a group of company, about 60 cottages, all in precast concrete, run to about 85,000 square feet, or about roughly 9,000 square meters, and some photographs. I'll show you what problems we encountered. And right now, the government of Tamil Nadu has given us an order to construct a 8 MLD sewage treatment plant using geopolymer concrete. It involves about 20,000 cubic meters of concrete in about 2 years. There was a lot of problem in getting this tender because there are no standards, and all the government contracts goes by standards. And we had an excellent consultant who helped us out. What he did is that he says we are calling this as Portland cement reducing agent. So we said 1% of Portland cement and rest all geopolymer cement. But in effect, what is going to happen is only the 1% of one particular area where they are going to use, will be using total Portland cement, and all other areas will be done by Geopolymer. And this is how we are able to tide over the situation. And I'll show you some sample castings which have come very well, and we have done in the last 6 months a number of samples for them, and the consultant is extremely delighted with the product, and of course we need to face all the issues. And we got a contract now for putting a 4.1 kilometer of fencing on a port. The same port we are also doing the coastal armor, and we will also be doing a lot of other work there. And this is for one of the leading construction companies in India, and this is a very prestigious work. And the government of Telangana, the new state that has been formed now in Andhra Pradesh, all the B-class roads are now to be laid in concrete. So we could get hold of the ministry, and then we laid a sample, and now we have got the first contract for laying a 42 kilometer of B-class roads of 7 meter wide. So this is the factory building of ours, which will be producing precipitated silica from the first week of September, about 50 tons per day. And this is nearing completion. And other than all the structural members, it's a 20-meter tall structure, and all walls, the roads, the flooring, all done by Geopolymer concrete. So these are some of the precast walls that we are now currently erecting in the port, and this is some of the very exclusive partition walls that we have designed and created for running the cables in our precipitated silica unit. You see, these are the top chimney blocks that we have made in Geopolymer concrete, and the total chimney was about 16 meters. We got a lot of chimney elements made now of different sizes. We made chimneys of 1.25 meters in diameter. So this is our product launch, and this is our team of Geopolymer with our the chairman, MS Jain, and these are all our members, our research doctors, 2 doctors. We have the CEO, and we have other directors, and the head of marketing, and the vice president business development, general manager marketing, and this is the team of Geopolymers in India. This is the photo taken during our launch. This is the photograph where I have shown you that when we have been doing the pothole repairs, and this particular photo was taken at night 1 a.m. And when even our chairman was sitting at the pavement to watch, and all the government officials were there. A very interesting observation here is they did the repair work of these potholes about 15 days ago. They used a phosphoric cement, very expensive. So we did it, and we have made, this is particularly a flyover, and where we have made about 87 patches. There's an old flyover, and all 87 patches are intact in the last 6 months. See, this is how we would like to take the business, keeping a lot of channel partners. See, as of now, we have 5 channel partners, and by the end of the year, we would like to have 20, and maybe 100 next year, and 250. Each one, we will be supporting them in with our materials, with our marketing network on a common brand name throughout India, and we will also support them to get bank loans to set up the units in case they are not an existing one. And moreover, we are picking up an equity in all these channel partners' ventures. The first 5 of them have been very successful, and one of them making insulation roofing tiles. He just commenced production last month, and the one person who has already been making concrete chimneys has converted 50% of his work to Geopolymer, and that's where we got our chimneys manufactured. And then there's a company with whom that we have aligned as a channel partner is making construction blocks, another one is making the block pavers, and the other one is making the fencing posts and panels. This is in addition to the capacity that we have our own precast, which we are now going to convert into a total training workshop, where we are going to train all these channel partners. And we have going to have a non-disclosure agreement and a memorandum of understanding where we will work in a partnership on a long-term basis. We provide a quality and certification for all of them, and we give a lot of assistance in the precast erection, and some of the channel partners are going to help us in distribute and provide logistic support. So this is some of the initial geopolymer activity that we have made. The road here you see is in a precipitate silica factory. In the office building, we have just created a road which is about, I think, 5 meter width and probably about 20 meter long. And you see here it's a restaurant very close to our factory where we have done with the precast elements, and this is a gentleman who gave us the cottage order. You see a very long casted pole, and this is a column for the fencing. It's measuring 4.2 meters long. So there you see the work that we did for the sewage treatment plant. It's a drainage channel first we constructed to test case our geopolymer. And this is a tetrapod that we made for approval, and it was approved by an authority in Singapore, and we'll be supplying about 6,000 tons, each one weighing about close to 3 tons. We are creating an exclusive facility in a port, and almost 70% of the work is over. The construction and erection is going on. Maybe from the month of September or October, we'll start production in that unit, and which will supply this to the government of Maldives. The contract is for about 5 years. This is the view of the cottages that I have been mentioning to you, and this is an architect's view, and this has been designed by a German architect, and his name is Michael, and a good friend of mine. Now you see here the rafters. Originally he designed the cottages with the wooden rafters, and after the floods then we thought the wooden rafters can't stay long, and some of the rafters made also floated and went away, and so it has been designed to concrete. And then when I talked to Michael, and we decided, okay, we will try geopolymer, and we did a small work in the restaurant first, and then we did it, and this is the rafter. This rafter is 8.1 meter long. The other portion where we have a connection to the other secondary rafters, it is done in situ, and for which we have made a separate mold to work in situ. And each rafter is weighing about 520 kilos. We need to cast totally about 3,000 rafters for this project, and this is a very prestigious product. And even the companies who are making Portland cement precast, they have failed. We have a 5-inch section and we have a 2.5-inch section. So the Portland cement could not withstand, and of course we took a lot of trials. The important part of this is the whole part of the molds were designed by us. We have first established a very good mold making workshop. The tetrapod mold was made by us, and all the products that you see here are going to see now, the molds are manufactured by us. These are all steel molds. It's a walkway, a sample walkway we have created on geopolymer concrete. I'm showing it very important because there are 2 colors of black and white, which are the most toughest color to make in concrete. You can make any color, but making black and white is the most toughest in concrete. And we did it with fair amount of success using geopolymer concrete. It's a small 20 meter we made, and we need a lot of walkways for this project. And the architect wants black and white. And it was a challenge, and it was addressed. So this was another type of fencing for this project, where you have a lot of planter boxes, where you can create a greenery, and the cottages have got a built-in big lake, the golf course, a lot of facility, and it's quite a big cottage project. So I'm just sharing some of the things, and as I told you, that we have our own well-equipped mold making workshop, which is the essential thing if you want to do precast materials. And we have made molds from PVC, rubber for small components, which we outsource it. We give a master mold, and then we get it outsourced from the market, and we develop our own steel molds. These steel molds are ceramic coated. And we have also done a Teflon coating, which works very well, but we are not able to recycle it for a longer time. We also did it with an epoxy coating, which also worked well, but again, the problem of recycling the molds. The ceramic coating lasts longer, and so we have established a ceramic coating setup. So we have an excellent ceramic coating setup because we need to do a lot of molds. It's a plasma coating. All our products are set and cured at ambient temperature. We have not done any increased curing at all. And we have a plant for manufacturing pre-mixed powder binders of a lot of mixed ratios of fly ash and GGBS. The issue here is the two things. If there are more fines, it consumes more accelerator. And if it is more moisture, then it's very difficult to control. So these are the two things we need to address when you are doing the pre-packing of powders. We are able to very effectively replace 30% of the usage of sand by using copper slag. Copper slag is available abundant in 3 places in India. So we were able to use it because the copper slag is literally free for us. And sand is the most expensive item. And sand mining is now restricted. So this is one very good move that we could make, and that's why we were able to make our concrete very competitive. And in fact, you will wonder that now we are selling geopolymer concrete lower than Portland cement concrete price. As you know that we don't add any water in the mix because it's all pre-tuned, and there are some cases only where we add water. Otherwise, most of the things we don't add water at all in our mix because we do the concentration levels of our accelerator and we modify it, because right now we are doing only precast work. When we sell, probably we may have to do a different one. We can give you a mixed design of a different types of accelerator and the combination of powder binders, which can set between 30 and 180 minutes. It's required in some cases. You need a faster setting, and you need, when you want to have a ready mix concrete and things, you need a longer setting. And just a thumb rule, a barrel of accelerator, about 250 kilos, you can make 1 cubic meter of concrete. It's just a thumb rule for you to. And may vary a little here and there, but it's just. And the very important aspect in our precast unit is the mixing of the concrete. The normal mixing of concrete in a pan mixer or in a barrel mixer or screw mixer, we are not getting proper results. So we spent a lot of time and we developed our own, we call it plow shear mixer. So it shears all the particles so that the activator is able to reach all the finer particles, and it's able to polymerize much faster, and it doesn't work with concrete. And another very important aspect why this shear mixer is used is when we add pigments. The pigments get a very good dispersion, so it's very useful. And we have made mixers right from a batching size of about 100 kilos to 1,000 kilos. And we are using the same mixer in now for a ready-mix concrete batching plant. So in our plants that we would like to establish, and 2 plants already commissioned, as I already told you, 50,000 tons per annum of each capacity, roughly about 150 tons a day, with an investment of 200 million of Indian rupees. So these plants are to grind the blast furnace slag and blend and also do the packing. We are not ready for the packing of this material to the market as a product because we need to have a lot of issues with the lobby of cement. So we are now giving it to our channel partners. And for the accelerator, we have commissioned 3 plants, and now we have a 20,000 tons per day. This is excluding our silicate plant. Silicate and this has got nothing to do. It is totally an accelerator where we have a blending facility and we have an exclusive manufacturing facility for making both sodium and potassium. And we also have a packing facility where we can pack it in jerry cans or in barrels. This is a product we want to put in the bags. Sorry about the activator, doctor, and it was made long back. And now we are changing it. And this is the standard powder. And we have one product called the Geocret where we mix all the ingredients of powder, all the powder things without moisture, and it is ready to use for repairs. This is the second largest steel plant in India. It's called the Vizag Steel Plant. Last 5 months after our launch, they are after us and we are after them. What has happened here is now on the 28th of June, about 10 days before, we have gotten a raw material linkage proposal that they have given us to use 15,000 tons per month of fly ash and 15,000 tons of blast furnace slag, and we are going to create a grinding facility inside the steel plant. They are giving us an exclusive place so that we save on taxes for transportation. We will be setting up our first 400,000 tons binder plant in Vizag in exactly 4 months from now. So this is the first government support that we got. It's a government-owned steel plant. And now we have more offers coming from the other companies. So this is the one which we got very recently. Yeah, these are the products that we are having in our shelf, which we would like to, which are ready from our research. Is the one is the Geocement, it's a powder blaze, and the other one is the Accelerator for the liquid, and then we have a Geocret normal, it's for the general purpose concrete, and we have a Geocret super, and it's a quick setting material, and then we have one for the wear resistant, we have called Tough, and we have Martyr, which has worked very well, and we have trained over 30 masons to work, and they have in turn trained about another 100 people, and it's a very big achievement by using this Geopolymer mortar. And then our compound on the fixing the tiles, it's come out very well. We have a mortar joint of just 2 to 2.5 millimeter thickness. I'm going to just tell you a case study a little later, what is the one that we did. And we have a plaster mortar, and it gives a very good finish. And it works with your plastering machine too. And then we have a putty, which is to fill up the gaps of all the things, and so on. So we would like to, the Geocement range, we want to have about 9 types of cements. This is how we take competition with the Portland cement. The first one is the general purpose cement, which we would even prefer to undersell to compete with cement, and which in actual case it is not required, but it is possible. A general purpose cement, and then we have an acid resistant grade where we use a mixture of sodium potassium, and then we have a temperature resistant cement where we use mostly potassium, and we have a chloride resistant cement, and then we have a ready mix concrete. And how to make ready mix concrete and setting time, I'm going to tell you how we have done it very successfully. And then quick setting, we have made a lightweight block, floats in water, and we did a good project of doing a panel. Not panels, and it's come out well. Right now we are working for insulation material. We are doing insulating roof tiles with a channel partner who is an existing factory where we have asked him to use Geopolymer in place of Portland cement, and he has successfully done it. And it took a lot of trials, and it was not so easy. And now we had to fine tune, and some of the molds we need to correct, and it has come out very well. And he has just gone into production. Probably we will go into the market from next month onwards. And we have made some retarders. These are required for making the ready-mix concrete. These are other products we are now under development in our R&D. We are having a waterproofing compound. We have a primary coat for all masonry surfaces. And then we have a heat resistant coating compound based on geopolymer. And there are 3 doctors who are working full time on this. And we have full-fledged laboratory to do this. And then we have an acid-proof application which is just completed, and chloride-resistant cement which is required for my tetrapods and for the pipelines. And shotcreting, we are just making some trials. The first trials are good. Maybe we need to do more work on this because basically we are a company. We manufacture silicate grouts for the underground tunnels. We have a silicate grout which can, which is a backfill for the your tunnel segments and when you do the tunnel boring, and this has to set in 20 seconds. So this is a material by which we started our work, and I think that's the starting point for us to get into the geocement business. The geofill is a low density filling concrete for all some sunken areas, and then we are coming out with a silicate based paint which is prevalent in Europe and US but not in India, and lightweight concrete as I told you, and 3D printing. So these are some trials that we conducted in Dubai. MAPE, you know, the leading company who manufacture a lot of additives, and then they are willing to work with us, and then we did a trial, and then they found the geopolymer concrete. He said it's awesome, and it's something great, I think. And they want to know how to package this, because if they sell geopolymer and their additive business will go. So they need to find somewhere in between. I think we are working out of methodology by which I think this product will be packaged. And these are the various type of hardeners that we have developed in sodium and potassium and also in feldspar. And we make in different type of molar ratios and different type of solid ratios and in different viscosities. Some case studies. I will just tell you about 2 of them. I'll take the case study number 2, where after the floods, there was a house where it was underwater for about 3/4 of a feet, about 9 inches. So after the floods started receding, then we filled up the house with the sand and geopolymer powder, dry mix, for about 2 feet. And we thought we have a big compactor, but it just got compacted very easily. And 2 feet we filled up. We compromised on our ceiling height. The present ceiling height was about 10 feet. We compromised and we took it to 8 feet, which is relevant in most of the countries. And 2 feet filling up was done. Then we laid the geopolymer concrete flooring, about 3 inches of flooring. And this time we used none of our factory people or trained masons. We took from the regular market people the regular concrete mixture and regular way, without giving them any type of a announcement that it is something different. So when they started concreting, first they said, "Where are the cement bags?" So when we started from the barrel, they refused. Then we gave them all protective things, all the gloves, helmet, safety glasses and shoes, and they started the mix. And when you mix in your normal cement mixer, that 1 bag mixer, it is very viscous. It's very difficult to take it. So that's one point. Then we started laying the flooring, all absolutely manual, because there's no access to other machinery there and no RMC, nothing. It's about 1,200 square feet, and it was done in about 3 hours. And after everyone was 1 batch mix, about 350 kilos. And the 3rd batch, when it was made, the mason was doing the leveling work inside, and I think they have added some water here to make the concrete flow a little more easier without anybody's knowledge. He came and started shouting, "Why are you adding water? The concrete is flowing beautifully. It's going like a silk. Why you want to add water?" So he came and shouted, stopped, and then the whole floor was done. And after an hour, we asked everybody to move, walk around, and they walked around, and there was no shoe marks, nothing. And actually, after 4 or 5 batches, they removed all their gloves because it was absolutely harmless, and they enjoyed. After 3 hours, we started laying the tiles. The entire 1200 square feet tiles was laid in about 4 hours, and the house was ready overnight for use. So this is a very important thing, whereas if you want to use a normal thing, I think you're going to wait for weeks. The house that we made is my own house. That's how it happened. So I know I can afford to take a lot of risk, but it was not a risk. And then followed this, there were a lot of people who came to me, and then they offered, and then a couple of houses we did later around, and it was a very good case study for us of the floods. And of course the pothole reports I told you, and then the fourth one is the sample oil well. See, in Egypt, the western Egypt, there was an oil well, and they were trying to put an oil well cement on these things. They were not able to arrest that because the gas was coming out at 200 degrees centigrade. So it was very difficult. So from the Egypt factory, we have asked them to formulate our Geocement, and then we took it, and then a sample well was plaqued, sealed very well. Okay, this is our new facility which will be ready for manufacturing accelerators of 100 tons per day. These are the storage tanks, and you see on the left is our reactors and autoclaves, this one. And this is our drum barrel filling facility for marketing. And this is a fully integrated facility where we can make close to about 300,000 tons of accelerator every year. So this is an exclusive facility only for accelerator and nothing to do with our silicate. Yeah. Now I just give you some of the observations and recommendations. The important thing is choosing the right type of accelerator and for the right job. So this is a very important aspect, and the next slide I'll tell you how to choose the accelerator. And equally important is the ratio of the powder mix of your fly ash and GGBS. And then your mix design, it depends on mostly on the setting time and what is your strength requirements. The cracks will come. Cracks are not uncommon to concrete. But how do you address? That's more important. Sometimes you have more fines and it develop cracks, and if it is under-cured, I know there is no curing, but still there is a curing of geopolymer concrete. It cures within. You demold it earlier, then it develops cracks. Another important problem is the effervescence. It happens when you use an alkali, higher alkali. You get white spots or different type of things that come out, and you will feel this when you put the product in water. And you measure the pH, you know how much of additional alkali that your product has consumed. Actually, it is possible to optimize and then work with a very low amount of silicate activator. When first in the year 2013, the conference I attended, they said we used to have a 22% of alkali. Now we work with 5%. There are dark spots in concrete. It is mostly due to the quality of fly ash. Maybe you have some coal particles or some other external things, so you get dark spots. So you need to take care of that. And some of the precast products change color. If you put water, it becomes dark, and after it gets dried, it becomes so. I think this is an inherent quality which we use it as a USP for marketing. We don't call it as a problem. We use it as a marketing ability. And the more fine of GGBS and fly ash is also not. You have a lot of fines, you have a lot of problems. So you have to work on a proper particle size to have the right concrete. Another important issue that normally comes to all geopolymer precast products is the surface roughness or abrasion. It tends to be soft in most of the cases, but it could be made hard, very hard. In case when we are doing some of the precast block pavers, we do a 2-layer casting. We lay a top layer casting which is very hard and We use a bottom layer casting which is normal so that the top surface is always maintained vibration resistant. Another advantage of doing the two layer is the top layer can be colored, pigmented. You can create designs. And of course, fibers in concrete, I think the best fibers are steel fibers. We have not been successful in glass fibers. We are somewhat successful in polyester fibers, and polypropylene fibers also not so good. Not given very big results, but the steel fibers have given a very good results for us. Maybe the reason is that the alkali is binding it very strongly with steel, and the shear mixer I've already told you. I think when you want to do, take a shear mixer, or you want a shear mixer, either order one or ask me, I will give you a design free of cost. This is something very important, and the type of accelerators we have used, the retarders we have made, and on different molar ratios. See, I have the samples here which I'm going to give it to you or show to you on different type of see, we make from molar ratios of 1.65 to 3.2. Many of the people will wonder what the 3.2 will do here, because the recommended ratios are 1.65 to 2.1. You see, the one I have is this, the 1.65 ratio with the 35% solid content. And we have this, actually this is a potassium. And this is a combination of potassium and sodium. The ratio of 1/3, 2/3. And this is also the ratio of 1.65 molar ratio, and with the solids of 35%. And this is sodium, 40% solid content, 1.65 molar ratio. I will tell you what the colors indicate there, and then I have this is a 1.85 molar ratio with a 30% solids, and this is a 2.1 molar ratio with 40% solids, and this one is a 3.2 molar ratio and 40% solids. I told you that we have made something with feldspar. The process has been different than what we make from normal silicate. This is using feldspar. It has formed a sediment, and this sediment is required. If you filter it out, it won't work. This sediment is very, very important. This is one of our latest testing. Now, this will be all right. And this is going to make the market, revolutionize the market, because this is the most cost-effective solution. Right now, we have made some color charts where in the 40% we have put some blue color, which means you can add water there. You can dilute, add water, flowability of concrete. We have made concrete, dry mix concretes. We have made self-curing concrete, self-setting concretes. We have made pumpable concrete. The one with the green, you can use it directly. No need of adding water. They are 30% solutions. They work at an ambient of 25 to 30 degrees, and you don't have to add water at all. See, the reason why we have now prepared a product where we don't have to add water is normally in India, the concrete mixing is mason controlled. And the masons, we do not know how much water they mix. And even for curing, how much water they use. And what type of quality of water they are going to use. We wanted to bring the art of making concrete from mason controlled to mason-less. So it should be an engineered concrete. So that's the reason why I want to prepare the solution so that there is no ambiguity in mixing. You straight away mix and start using it. And that's the reason why we are going to give the powder packs of different combinations. Next slide. And the 3.2. Given, this is used as an excellent retarder of concrete. Only thing is the dosing is very important. If it is used effectively, it is an excellent retarder. You want to extend your setting time, don't use anything else. Our experience, we have done ready-mix concreting for keeping it for 3 hours, works well. As a part of this, our geopolymer activity, we regularly conduct workshops in the schools and in the colleges, and we have trained more than 250 students to work on, because they are the future of tomorrow, and we will be asking for geopolymer concrete from day one. So there is a team of people who go and train and give workshops in colleges. We have aligned with about 10 universities in India. We have a training center now where we train the supervisors on how to have a different type of mixes, mix design, mold making, precast, all those things. And we conducted an exclusive workshop for architects. 6 architects took part, the top 6, and all top 6 are now giving us orders. So this is one of the approaches that we have taken, and wherein we are able to establish marketing of our Geocement products. Another very important slide is the ratios of fly ash and GGBS. It could be any of these ratios. It could be 50-50, 60-40, 70-30, 100% to GGBS, 100% fly ash. Anything is possible. But the thing is, we have to use the right time of activator, and then what strength that you need. You add more fly ash, sometimes you get a lower strength, and you add more GGBS, you get a higher strength, and you get a quicker setting. So when you do, sometimes your alumina content, the sum of alumina content in your fly ash and GGBS, if it is less, we separately add alumina to compensate. Otherwise, it doesn't get set properly. Some of the fly ash samples. So once you standardize on a fly ash, there is no problem. But if the alumina content is low, then you need to compensate with your external aluminum oxide. Even the Class C fly ash can be used for quick setting, but it should be used on site, and it's not a commercial preposition, but you want to do your own job, Class C you can use. And as I told you, the finer the particle size, you need a more hardener. And we prefer the blast furnace slag. The other slags we don't prefer because you don't get it regularly, and you can't sell them commercially. So the blast furnace slag is one product where we can sell them commercially. We don't use metacoiling because it's very expensive in India, and we cannot sell a good product. We can make one, but we cannot because it's about 3 to 4 times expensive. Yeah, this is the selection of accelerator. I think the professor has already told you yesterday the ratios. I think the one on the green band of 1.65 to 2.1 are all favorable areas. They are stable, they are workable, and we call them medium alkaline. And the other one we call a strong alkali. They are hazardous and they are corrosive. We don't use them. And the one on 3.1 ratio or 3.3 ratios here, we call them a low alkaline or a neutral grade. And this can be used as a retarder, in some cases as a plasticizer. And I think this is what I think everybody will be interested. And given some costing analysis in India, we compared 3 type of accelerator combinations, and what you see is a 100% mix of sodium 1.85 40% and the potassium and the feldspar of 1.65. And how much quantity that approximately we use, I have corrected to the decimals, and then the water content you use and the cost in metric ton. What you see outside is the cost of concrete, and what you see in the bracket is the cost of accelerator. This is Indian cost, and this is just for a reference for you. I have made the feldspar a small combination there. What is the feldspar that we use is with a 65% silica, and 17% alumina, and 15% sodium and potassium, and 2% iron, and plus 1% of those. And this is the type of feldspar that we have been using to make an accelerator. This is a new one, and we are just filing the patent, and we already hold the 3 patents of different products. The 4th one we are now filing, and I thought I would share about this new development to you. These are some plans that we have in 2016-17. We want to be present in totally in India, in the MENA region, that's the Middle East and the North Africa, and also in South Africa, because South Africa we will be present soon. And we would like to address the market of the Europe, UK, and the Far Eastern market through distributor system. And we will be establishing plant in China and USA, and in Australia we will have another distributor. So the plant in USA is certain, and plant in China is certain for us. So this is how we would like to take it up in the next 3 years. And perhaps this last slide, where I would like to give you some of the food for thought I said yesterday. Before that, anybody here want to have samples of silicates for research and development? It's available free of cost, but the only problem is logistics. And last year I had sent 1 kg of sample to a person in Poland, where I spent 230 euros for transport. So this is one of the problem, but I can give you free samples. Mappe Sheikh sample from us from Dubai, which is free of cost. And about 24 research institutions in India, we supply the material free of cost. And anybody here, we can supply. The problem is, if you can bear the logistics, we can give you the right ratios with all the technically perfect accelerator. So now, we've been talking about yesterday about the 3D printing, and about coastal armor, and some plastic composites by other gentlemen, and uses of geopolymers in automobiles, as I was supposed to told. And there was some article on the canal embankments, where we want the fishes to grow. There's a geopolymer is an excellent material, where you have a design of blocks. A Korean has given me some thought and designs, which I thought I will share. And actually, I've been manufacturing a lot of geopolymer products in my mind. So I thought it's endless, and this is what I want to conclude with a note. See, today is the world and time of IoT, Internet of Things, and connectivity. These 2 things are going to take the whole world maybe next 5 years. Whether it is Tesla or whether it is, I think it's going to be, these 2 are the critical words. How do we associate this with geopolymer? Geopolymer is also, yesterday as Michael has put it, it is something very disruptive, and it has an exponential growth. We have to align. Probably we can design some solar geopolymer panels where you can do away with the aluminum sections, where your solar modules can be integrated to your roof. We can make a lot of intelligent geopolymer products. Some of them are, see, we have made some curbs with holes for running your cables, broadband cables, TV cables, where you don't have to cut the road to repair. You just remove the curb and then do the repair. And if I keep a sensor inside the curb, you know where the problem, where there is a water, where there is a puncture or whatever it is, you can address that very easily. So the curbs are designed to run cables. It's a very big market, and I think it's something which the world will welcome, because otherwise now we cut down on the pavement, you cut down on the roads, and then parking sensors, you have the blocks with sensors. So this is how you value add to your geopolymer. Don't compete with cement. You value add yourself and then make an individual product, branded product. It does sell. So in a pedestrian crossing, you have a geopolymer block. When 4 people stand, the lights turn green. You walk. And then you put a sensor in your beams and study the deflection, study what is happening, what is the life cycle. The sensor is very, very cheap today. I think yesterday some of the presentation, they made some sensors in various aspects. I think it must be a very good. And why not we have LED lighted floor tiles in the walkways, in gardens, in pedestrian areas? Very big market. So these are some thoughts which I'm sharing with you. Maybe you have more and then more to come. Thank you. The last slide. And then you have any requirements, we'll discuss it at the tables. And then I think this is a time from when we start interacting, we start sharing, and then we start mutually doing more to the world with a lot of geopolymers. Thank you very much.